I'm going to show you how to convert a fraction to a decimal. And if you take a look at the top of your screen, it says divide the numerator by the denominator and round if needed. So that's exactly what we are going to do. Now I'm going to do a few of these by hand, a long division problem to show you exactly what's going on. And then the others, I will give you the answer that a calculator will give you and show you how to interpret everything. So let's jump right into number 1, where we have 2/5 or 2/5. So here, again, divide the numerator by the denominator. So 2 divided by 5. And this fraction is less than a whole, so our decimal is going to be less than a whole as well, because this decimal is going to be equivalent to 2/5. So we can't do 2 divided by 5, right? We can't take a whole group of 5 out of that 2. So we need to extend our division problem by putting a decimal and a 0. So now we can think of that as 20. Bring our decimal straight up. How many whole groups of 5 can we pull out of 20? Well, 4. 4 times 5 is 20. Subtract, and we get a 0, and that tells us we are done. So 2/5 is equal to 4/10. Equal to 4/10. Number 2, 9/25. I'll do this one by hand as well. So 9 divided by 25. So we need to extend our division problem with a decimal and a 0, because we can't do 9 divided by 25 and get a whole number. We can't pull a group of 25 out of 9. So now we think of this as 90. How many whole groups of 25 out of 90? Well, 3. 3 times 25 is 75. Subtract, we get 15. So we did not get a 0 right away like number 1. So we can extend this division problem by putting another 0 on the end. A 0 to the right of a decimal doesn't change the value, so we're not changing the problem at all. Now we can bring that 0 down, and we have 150 divided by 25. And we can pull 6 whole 25s out of 150. 6 times 25 is 150, and we get that clean-cut 0. So we do not need to go any further. We are done. And that problem kind of ran into the top problem there. But our answer is 36/100. So 9/25 is equal to 36/100. Let's take a look at number 3. Now number 3, if we were to plug in 3 divided by 16 into a calculator, we would get the following decimal. And it goes to the 10,000ths. So it's typical to either round a decimal to the thousandths or hundredths. So we're going to round to the thousandths in this video. So we would take a look at what's in the thousandths. Look next door. That 5 says round up. We are closer to 188 thousandths. So our rounded answer would be 188 thousandths. So that rounding step depends on what you're doing with the problem. Maybe you wouldn't round that decimal depending on the situation. And as we'll see with number 4 and 5, we can have decimals that are much longer than just to the 10,000ths place. So speaking of number 4 here, we have 1/3 or 1/3. And I'm going to show you this by hand, and hopefully you'll notice a pattern as I start doing this one. So 1 divided by 3. So again, this is just like number 1 and 2 where we wrote them out. We can't pull a whole 3 out of that 1, so we extend with a decimal and a 0. Bring that decimal straight up. So we look at it as a 10. So how many whole 3's can we pull out of 10? Well, 3. That gets us to 9. 3 times 3 is 9. Remember, we want that clean cut 0 to tell us that we are done. So we need to add another 0, drop it, so we have another 10. How many whole 3's out of 10? Well, 3. 3 times 3 is 9. And our pattern is going to start here. Subtract, add another 0 and drop it. So we have another 10. 3 3's out of 10. 3 times 3 is 9. Subtract a 1. And you're probably getting the point here. It's going to go on forever. So it's a repeating decimal. So our answer, this is one we would want to round. And if we round it to the thousandths, we have a 3 there. Look next door, it says stay the same. So our answer is 333 thousandths. Or if you have a repeating decimal, you can write whatever number's repeating and put a bar over it, and that bar signifies that that digit just repeats. Okay, so 2 ways to do that. You can round it off, or the bar shows that that digit repeats. So number 5, we actually have an improper fraction. So this is going to be above 1 whole. It's greater than a whole. So if you plug 17 over 11 or 17 divided by 11 in on a calculator, you're going to get 1, 54, 54, 54, and it's just going to be 54s repeating. So again, we can round to the thousandths. So a 5 there. Look next door. That 4 says stay the same. So our rounded answer would be 545 thousandths. So 1 and 545 thousandths. Or we can use the bar method. I forgot to circle my answers for number 4 there. Just noticed that. Or we can use the bar method, so 1 and a 54 repeats, so we can put our bar above the 54 to show that that will continually repeat. Number 6, 17 over 20, so 17 divided by 20 is going to give us 85 hundredths. So it cuts off in the hundredths place, so no need to round. That one works out nicely. So there you have it. There's how you convert a fraction to a decimal. Divide the numerator by the denominator, and then interpret your answer. Do you need to round? Is it a repeating decimal?